Hello, you are welcome back. All right, so let's continue from where we stop now. We're going to be looking at Newton's third law of motion. Okay, so Newton's third law of motion is also known as the law of conservation of momentum. Now, what does it state? All right, it states that for every action, there's an equal and opposite reaction. So, in a simple term, action and reaction are equal. Action and reaction are equal but opposite. Okay, so they are opposite. So um action is equal to reaction. Action is equal to minus reaction. So let me illustrate this. How do we illustrate that? Okay, let's say there is a floor that actually withstand the weight of an object. An object is placed on this floor. Okay, so the weight of this object is actually acting downward. This is the weight. Then for this floor to actually withstand the weight of the object, then it has to react in opposite direction to the weight. Okay, so it's going to react, and that reaction is actually upward. So that simply means that for this floor to actually withstand the weight of this object, the weight being the action is equal and opposite to the, of course, the reaction. So please take note of this. Okay, so Newton third law actually also referred to as the law of conservation of momentum. Okay, law of conservation, law of conservation of linear momentum. So according to the law of conservation of linear momentum, okay, uh, it actually states that the momentum the momentum of bodies before and after their collision is always constant. All right. So to actually simplify this, whenever collision is actually take place between two bodies, the momentum the momentum of the bodies that is calculated before the collision is equal to the momentum after the collision. So the momentum does not change. Okay, it's not created, it's not destroyed. Okay, so every time you have conservation, it's simply a statement of not created, not destroyed. So that's simply whatever it is. Whatever is it is before is always going to be the same amount after. Momentum before collision is equal to momentum after collision. So that will actually lead us to uh, look at the different types of collision. Okay, so because Newton's third law actually centers on collision, because action and reaction has to do with collision, because an action impact on a body is basically on the basis of collision. So what are the types of collision? Two types we are going to be looking at. The first is inelastic collision. Okay, the first type is collision known as the inelastic collision. Then the second is the elastic collision. Okay, so let's start with the very first, which of course is the inelastic collision of two bodies. So as the word inelastic actually implies, it simply means that the collision does not actually involve rebounding. That means the two objects, when they collide, they don't move in opposite direction, but rather they move in one direction, in the same direction. Okay? How do I illustrate that? So I have a mass m1. Okay, let's say probably moving with a velocity, initial velocity of u1. Okay, then coming to collide with another mass m2, or having initial velocity u2. Okay, it might basically it might be at rest, or you might be moving in a slow. It might be slow. So this one is moving faster. Then it comes to hit on this particular mass M2. Now at the end of the day, two of them will actually will move in the same direction. So M1, M2 we actually will coalesce or will combine together, and they will not move in opposite direction. They will move in one direction. So this is gonna be the combination of M1 and M2. This is M1 and this is M2. Okay, so they will now move in the same direction with one common velocity, that is the final velocity. So from inelastic collision, we can derive a formula, okay, of conservation. We are told that momentum is conserved, all right, in any in the from the law of conservation of momentum, momentum before is equal to momentum after. So in inelastic collision, if we measure the total momentum of these two bodies before the collision, okay, then definitely enough. If we also measure the momentum of the two bodies after their collision, then the momentum before the collision is equal to momentum after the collision. That is why we actually conclude that momentum is conserved. So let's actually look at the formula. Okay, so what do we do? The initial momentum of the first body is m1 u1. Remember, momentum is always mass times velocity. Then the momentum of the second body is m2, then u2 is equal to the final momentum of the two bodies. So the two bodies combined together, that is m1 plus m2, then multiply by their velocity, common velocity. Okay, so this particular formula here is a formula that is used, okay, to actually do calculation in as much as in elastic collision is concerned. All right, so let's look at some examples that illustrate this particular formula. Example, let's look at a situation where we have a mass, a ball, of course, of mass, um, let me say, okay, the ball of mass 20 grams, okay, initially moving with a velocity of 20 meter per seconds. All right, then comes to collide with another ball of mass, let's say 10 grams, and this ball is not moving, it's at rest. So the initial velocity of the second ball is 0 because it's at rest. So the question is, calculate their final velocity after their collision. What is the final velocity after their collision? So this is, once you see this kind of collision, all right, where one object comes to collide with another object and they move in the same direction with a common velocity, then that is inelastic collision. Then you would definitely have to apply this formula. So let's apply the formula. So solution. So let's see what we have. So I have m1 u1 plus m2 u2 is equal to m1 plus m2, then multiply by v. Let's see what we have. M1 is 20 as a matter of fact. All right, then times u1, which of course is 20 plus m2, which is 10 multiplied by u2, which is 0. Okay, so that's going to be 20 plus 10, m1 20, m2 10, then multiply by v. We're looking for v. All right, so let's see what we have here. 20 times 20 is 400, and of course plus 0 is equal to 30v. So v invariably now is going to be equal to 400, then divided by 30. Okay, so we can actually do that division, and uh, we'll end up having, okay, some fraction. Okay, so we'll have some fraction. So let's do that division. 40. I've already cancelled 0. So I'm doing 40 divided by 3. Okay, so let's see what that actually gives us. 40. Okay, 40. What do we have? Okay, so let's see what we do have. Okay, 40. Okay, so 44. Let me get this. Okay, so here we go. Okay, so 40 uh 40 divided by 3. Okay, so what do we have? 13.3 33. So that's gonna be the velocity we're looking at is 13.3 meter per second. So right, so this is in elastic collision, and of course in the next video we are going to talk about elastic collision. So that is it for this video. So see you in the next video. Thank you very much.